Hi everyone, this is Team 13 and Poster 34. We are going to present our project on human activity recognition. Uh, this slide shows a visual representation of what we are going to do in this project. So the main aim is to predict the activity being done by a human being based on the sensor data taken from a mobile phone. The main motivation for this project comes from its applications in various domains like healthcare monitoring, fitness and sports, security surveillance to identify suspicious behaviors, track physical activities, and analyze different activities. This domain holds an immense potential for transforming various sectors and is a crucial area for research and development. Hence, we have chosen this project. We have taken the dataset from UCI Machine Learning Repository, and this dataset contains data in two parts. The first part is the original time series signal readings of the accelerometer and gyrometer signals. The second part is the process data by applying some transformations to extract the features, and around 560 features are extracted for each record. And the output is a multi-class attribute representing the activity being performed. So the activities are represented with numbers from 1 to 6, and the activities include walking, walking upstairs, walking downstairs, sitting, standing, and laying. This graph shows the distribution of frequencies across different activities in the dataset. The task for this project is to improve the accuracy about the baseline SVC model for recognizing the human activities. We aim to achieve this by exploring various neural network architectures like CNN, LSTM, etc. The baseline model is a support vector classifier. This transforms the original data space into a high dimensional feature space and finds an optimal hyperplane by maximizing the margin between them to separate the classes. And since this is a multi-class classification problem, we are using one versus all strategy to decompose the original classification problem into multiple different binary classification tasks, and we take a high confidence vote among the n classifiers to find the target class. So these are the results for our baseline model with a training accuracy of 95.3% and testing accuracy of 92.4%. And the figure on the right side shows the confusion matrix. As we can see, certain classes are being confused a lot with the other ones. Hence, we want to explore some neural network architectures which have a better performance in this classification. So the first architecture that we explored is the convolutional neural network. For this, we have segmented the time series data and constructed a 3D NumPy array with this shape, where the first dimension, that is the 7,352, represents the number of segments, and 128 is the length of each segment, and 9 is the number of features. Similar segmentation is performed for the testing data as well, and this input is passed uh, to the first part of the architecture, that is the 1D convolution layers with kernel size 3 and filters 32 and 64 respectively. The flattened output from the after the convolution layers is fed to the 3-layer MLP. The hidden layers have 256 and 128 neurons respectively, and the output is a softmax layer. The optimizer used was Adam and categorical cross entropy laws with 20 epochs of training. The results of CNN are shown here with training accuracy of 97% and testing accuracy of 94.2%. As we can see that the accuracy is clearly above the baseline performance, and the confusion matrix on the right side shows an improvement in the way the classes are being identified than the baseline model. The next architecture we explored is the convolutional LSTM. So the training and testing data is same as before, the segmented data, and it is fed to 1D convolution layers. But here we are using more number of filters with 64 filters followed by 128 filters and a kernel size of 3 with activation function ReLU. Then we have max pooling and dropout. And this is given as input to the LSTM layer with 100 units to capture the temporal dependencies. At the end, we have a 64 neuron dense layer and followed by a final softmax output layer for classification into 6 activity categories. The optimizer used was Adam and sparse categorical cross entropy loss. The results of convolutional LSTM are shown here. We can see that the accuracy of CNN LSTM is the highest with 94.8%, and and the confusion matrix is shown on the right side with good performance. So the conclusion is that the convolutional neural network and convolutional LSTM had performed better than the baseline SVC model, with CN and LSTM having the highest performance with 94.8% accuracy on the test data, and a convolutional neural network having performance of 94.2% accuracy. Thank you.